In studying trigonometric functions, each trigonometric function has what we call a period. Um, and that comes from its periodic nature, how it repeats its value over time. Um, we'll get there in a minute, but the idea is that each trigonometric function we know has a defined domain and range, right? We know, for example, sine has a domain that is all real numbers, so we can put in any angle, right? And its output is restricted between -1 and 1, okay? When we go around the unit circle enough times, right, the sine value, the y value, ends up repeating, right? Once we go around 2 pi, well, all the y values have already been accounted for within 0 to 2 pi, but we can have those output values repeat even though we have a unique angle, okay? So that's where the idea of the period of a trigonometric function comes from. We can see the formal definition here. To me, it's kind of like reading gibberish, but the idea with the period is it's this minimum number p needed for it to begin repeating its outputs. And I mean all of its outputs, not just some of its outputs. So let's think for a minute for cosine. What could the period for cosine be? Okay, well, for cosine, remember cosine is looking at all possible x values. Okay, really and truthfully, because we're taking x over 1, and on the unit circle, that 1 just doesn't cause any major hurdles for us. So if I look at cosine here and the x values, right, I have 1 up to here, and then so then we continue going around. These are all unique, right? The outputs for cosine are all unique up to here. And then we start to repeat the values, right? So then the question is the period just pi? Because all these values then begin repeating. And the answer is no. And the reason for that, so the period for cosine is actually 2 pi. Okay, so it's one full rotation around the circle. Okay, why is it 2 pi instead of pi? The reason for that is that if we look at the coordinates connected, so not just the x values, but if we look at the y values as well, or the point as a whole, right? Even though we have, for example, square root of 3 over 2 as the same x values for 150, sorry, negative square root of 3 over 2 for 150 and 210, they have different y values. So we really want to figure out, okay, well, where do we have repeated points, repeated coordinates? And that actually occurs one rotation around the circle. Okay, so even though the x values are repeated, they have different corresponding y values. Okay, and so for that reason, cosine and actually sine, for similar reasoning, also has period 2 pi. Okay, so cosine and sine repeat their values every 2 pi. Additionally, you might imagine that they're reciprocal functions, so secant and cosecant also have period 2 pi for same reasons that sine and cosine have period 2 pi. So then notice I did not list tangent here. So the question is, what is the period of tangent? And, well, probably cotangent too. These ones are actually going to have period pi. And remember that tangent when we defined it. So if I do tangent of an angle, right, it's the ratio of the y coordinate to the x coordinate. So if we imagine taking, well, we can't do, we can do 0 divided by 1, that's fine. But if we imagine taking all these divided by each other, right, these are all going to be positives because we take, positive divided by positive. And then here we're actually undefined, but then we do, all these are all negatives. Okay, these negatives are going to be exactly corresponding to the same angles here, so they're repeated. So really the unique case of tangent is from 0 to pi, or different versions, but every iteration of pi, you end up repeating values of tangent. okay, for the same angle. All right, so we have rough ideas of what the period is. How is it used? I think that's our next best thing to tackle, okay? So the period property I often refer to as the periodicity of the function. So how is that useful, okay? Well, the idea is that of the period is that it repeats its value. So we might be given an angle and say, well, that's fine. We could punch this into a calculator, get a number, move on with our life. But maybe there's a little bit more thinking that we can do, okay? Because if I dissect this just a little bit, right, I want to look at the angle a little bit more. So sine of, and 17 pi over 6, I'm trying to think like, how would I put that on a chart? Like if I had to, make a chart of this angle, right? 17 pi over 6, well, that's like a little bit under 3, right? But so I could separate it as like 12 pi over 6 plus 5 pi over 6, right? Which, let's see, is really saying sine of 2 pi plus 5 pi over 6, okay? Here's the next key step. Watch this. I can actually remove the 2 pi, okay? Granted, okay, so here's why I can remove it. We said before that sine has a period of 2 pi, meaning every 2 pi or every multiple of 2 pi that we have, it repeats its value, right? So whether I were to go to 5 pi over 6 or, go around the circle and still land at the same coterminal angle, okay, the y value is going to be the y value is going to be the y value, okay, no matter what I have for that coterminal angle. So why not make it easier on myself and go with something that's easily found using the unit circle, okay? So really the periodic property or the period property being 2 pi allows us to say, okay, well, instead of looking at 17 pi over 6, I can look at 5 pi over 6. Now, that isn't to say, here's a caution, okay? I am not saying that 17 pi over 6 equals 5 pi. I fully recognize that these are different angles. However, they are coterminal. Okay? In any case, we'll go through a few more examples, but in any case, when I have this, now I can go to my unit circle and say that sine of 5 pi over 6 is 1/2, and then I'm done. Okay? To me, that's a little bit easier than trying to think, okay, 17 pi over 6, where is that? And I'm probably actually thinking about the coterminal angle instead when I'm doing this problem myself, so why not communicate it here? Okay, so now, next example. Tangent of 5 pi, okay? I'm just going to make a note that, okay, for tangent, the period is pi, right? So I'm trying to think about, okay, what's coterminal with this? Well, tangent, well, I can say take out, so this would be, pi plus pi plus pi plus pi plus pi, okay? It's pi added together 5 times, right? Well, I mean, I can take out all multiples of the period, right? That's what I did up top when I was doing this step, right? So if I know the period is pi, okay, take out a multiple of the period. Well, I'm left with 4 pi now. Okay, well, that's still a multiple of the period. Take another one out, take another one out, take another one out, take another one out. And I'm left with tangent of 0. Oh, okay. So then I've removed all multiples of the period that I can, so now I'm just left with something that's easily found using my unit circle, and I can say that that is 0 over 1, which is 0. Okay. Now, I showed you one way to do your work. Granted, I could have also done this. I said, okay, 5 pi is coterminal with tangent of pi as well, right? So it's 5 half circles. And this would have been 0 over -1. Guess what? It's still equal to 0. So you can show your work in different ways and arrive at the same thing. Last example. For this one, I'm actually going to start off by doing the periodic or the even and oddness property. So since it's even, I'm going to say this is equal to cosine of 15 pi over 4, okay, using evenness, okay. And now I'm going to try and find out like where would this be on the unit circle. So cosine of, and then I want to look for something that's a multiple of 2 pi. So I know if I'm in fourths, 2 pi would be the same as 8 pi over 4, and then the remainder would be 7 pi over 4. Okay, so this is cosine of 2 pi plus 7 pi over 4. And I wanted the 2 pi to pop out because that's the period of cosine. So then I can remove multiples of the period. So this would be cosine of 7 pi over 4. And then this is on the unit circle in quadrant 4, and this ends up being square root of 2 over 2. So the idea with periodicity, translate from something that isn't on the unit circle to something is by adding or subtracting multiples of the period. Okay. Keeping in mind that the period of sine and cosine and their reciprocals is 2 pi and the period of tangent is pi.